So as we have our gradients and calculations based from points as we had before, and also calculations which can be taken from the equation direct, we are being asked to state which of the lines that are parallel, lines which are parallel to each other in terms of the gradient. If you are given two lines, all right, let's say this is our Cartesian plan and two lines are drawn parallel to each other. All right, so let's say for this line and also another line. These two lines, they are parallel. They do not meet. They maintain equal distance throughout. Those lines will be parallel. So let's say this is the first line and this is the second line. For these two lines to be parallel, their gradients are supposed to be what? Equal. M1 is equal to M2 in terms of the calculation. Let's say this is y is equal to 2x plus 3. This is y is equal to 2x minus 1. When these two gradients are the same, these two lines will be what? Will be parallel. So that is for what? For parallel lines. For parallel lines. M1 is equal to M2. That is, they have what? They have equal gradients. Equal gradients. So if two lines are parallel, they've got what? Equal gradients. So this is the first part. And the second part is when two lines are perpendicular. Perpendicular meaning to say they meet at what? 90 degrees. So let's say this is the first line and this is the second line. When they are perpendicular, the product of their gradients will give you a -1. So that is for perpendicular lines, which is a rare situation for O-level mathematics, but you must also understand that that is for what? Perpendicular lines. All right, M1 times M2 is equal to -1. The product of their gradients, the product of what? Their gradients. Their gradients is what? -1. So that's when you multiply their gradients, you're going to get a -1. So that is it here, gradient concept. All right, so they will be asked A to find the gradients. Then now after you state which of the lines in A are parallel. So there is no way, guys, we had to calculate these gradients. All right, so I'm just going to quickly go through this. All right, so this is x1, y1, x2, y2. Remember our formula for the gradient. That is, the gradient is simply the change in y over the change in x. So that's it. Y2 is 7 minus y1, which is 3, over x2, 7 minus x1, 1. So 7 minus 3, that was going to give us 4 over what? 5. Over 6. Oh, this is 6, sorry. And divide by 2, that's 2 over 3. Okay, verify and see. 7 minus 3 over 7 minus 1 is 2 over 3. All right, so the first one, the gradient is what? The gradient was 2 over 3. Okay, let's move on to the second one quickly. So guys, we talked about this. That's why I'm just rushing here. So this is the same one, y1, x2, y2, and for the formula, let me just write the formula here, and I'm not going to repeat. I'm just going to substitute into the formula. So y2 is what? 4 minus y1, that's a 0, over x2, that's a 0, minus x1, which is -3. So take note about that. So that's going to be 4 over minus minus, that's a plus, it's 4 over 3. So here the gradient is 4 over 3. Okay. The next one, we do the same thing as before. So y2 minus y1, 6 minus, what are we subtracting? -2. Okay, over x1, 3, x2, I mean, 3 minus x1, which is what? -5. So that's, we're going to have negative, negative, positive. So that's 6 plus 2, 8. Here, positive 8 again. So that's 1. Okay, so here the gradient is 1. Okay, let's move on to another part. This one, x1, y1, x2, y2. We have our gradient just like before, y2, 0, minus what? y1, which is 1. Okay, so that is 1 here, over x2, which is 2, minus x1, which is 0. So that was going to give us negative 1 over 2. Okay, so that's our gradient here. Negative 1 over 2. And the last one is going to be our x2 negative 1. I mean y2 here and y1 negative 3. So we subtract minus 3 over what? x2 negative 2 minus our x1 negative what? Negative 5. Okay, so let's see negative, negative, positive, positive. So minus 1 plus what? Plus 3, which is 2. Minus 2 plus 5, which is what? 3. So that's 2 over 3. 2 over 3. Okay, so we have these gradients. Then D, we are being asked now, state which of the lines in A are what? Parallel. Which ones are parallel? The ones that have got what? Same gradient. So we're just going to look into the ones with same gradient. Right, we have 2 over 3. Yes, there is another 2 over 3 here. So these two lines have got same gradient. So that's item 1 and what? 5. Those are the ones that are what? Parallel. 4 over 3, we do not have that. 1, we do not have minus. So these ones, they are not. It's just 1 and 5. Those are the two that are parallel. All right. So here we obtained minus 1 over 2. Okay. And that was 8 over 8, which is 1. Okay, these are not. So only the first one and the fifth one, they have got what? Same gradient, just like that. So that is how you state same gradient for lines that are parallel. M1 is equal to M2. They have equal what gradients? It's all about the equal gradient there. It's all about that, the equal gradient, sorry, here the equal gradient concept, all right? So that is the concept. Then which of the following lines are parallel on this question? So here, what you need are the gradients. Remember, I told you guys, if you write equation in the form of y is equal to mx plus c, where y is the subject, m is your gradient, the coefficient of x. That was our previous class. So meaning to say, here we can even tell, because y is already the subject in these equations. So what are the coefficients of x? The coefficient of x. So we can see that for the first two, I mean for A and C, here it is 1, this is 1. So here it is minus 2 and minus 2. So these two lines, they are what? They are parallel. These two lines, same gradient, minus 2, minus 2. Here the gradient is 1, here the gradient is 1. These two, they are also parallel. They have what? Same gradient. So that's how you play around for parallel lines, all right? But in any case that they're going to ask you, because you know, exam, they can just ask something. When they ask about perpendicular lines, you work with the product of gradients, all right? But for parallel lines, same gradient, just like that. So let's do revise. This is our gradient concept in general, and this is going to help us later on in terms of revisions.